What is a decoder? In the previous video, we talked about the encoder and we define what is the encoder, its function, and we said that the encoder will encode some number of bits to a smaller number of bits, where the 2n will be the input and the n will be the output. And in this video, we will talk about a decoder. And in a decoder, if we have a decoder circuit, it will have n number of input and it should produce 2n outputs. And we will understand this decoder in terms of a circuit symbol, and we will look at in terms of the circuit diagram, and we will consider the truth table, and we can also look at the expression of the decoder. And at the end of this video, I believe you should fully understand what is a decoder and why is it useful in a digital system. In terms of the application, a decoder is mostly found in digital systems such as a computer, where the CPU will mostly require the encoder that will encode the number of bits and will produce 2n number of output. That is why it is important that from the n number of input to produce the 2n number of output in a system is very unique. And we have the encoder that will actually encode the value, pass it through a transmission track, and at the end it can be able to decode this encoded information. And since it is a combinational circuit, we require that any change in the input at that instantaneous time will be equals to the change in the output at that instantaneous time. That is why it is called a combinational circuit. And we will start our discussion by looking at a decoder, and it is nothing but a 2 to 4 decoder. And the symbol, or we call it the circuit symbol, we can be able to redraw such that we have two inputs. So we have 2 to 4 decoder, and we should have two input, and we can say I0 and I1, and we should have 4 output from the definition itself, 2 to 4. So we can have Q0, Q1, Q2 and Q3. Therefore, whenever there is 2 input bit coming in, it will be able to produce 4 output bits. And from the circuit symbol, we can now generate the circuit diagram where we have I0 and I1 as an input, and we have 2 NOT gate and 4 AND gate, and these gates are now responsible to provide our 2 to 4 decoder. And we will generate a truth table, and then we can relate how the circuit diagram will function based on the truth table. And now this is our generated truth table, where we have the number of input, which is the I0 and the I1, and we have 4 number of output. To understand, when we have 2 to the power 2 input, we'll now be able to generate 4 combinational output only. Therefore, we have 1, 2, 3, and 4, and nothing else. Because of these 2 combination input, it will now produce 4 combination of the output. And that means when we apply a logic 0 and 0 at the input, we will have the Q0, which will generate a logic I. And same for 0 and 1 all the way to 1, 1, where we have logic I at Q3. And now we are going to see how this truth table actually works corresponding to the circuit diagram. Now when we have 0 and 0, at the input, what will happen? And from this we can be able to see that the output of the NOT gate here will be 1 and here will be 1. When we have 1 and 1 passing through the first AND gate, we know that the output of Q0 will be 1. And how about here? Here we have 1 and we have 0, because this 0 is from the second NOT gate, and here we have 0 and here we have 1 and here we have 0 0. Therefore this will be 0, this will be 0, this will be 0. So the moment we apply 0 and 0 logic state at the input of the 2 to 4 decoder, Q0 will generate the output which is high. Therefore from this truth table we can see that Q0 is high when we apply a logic 0 at both the two input. And now what will happen when we apply 0 and 1 at the input? And we have 0 at I0 and I1, we apply a logic 1. And we all know that the output of the first NOT gate will be 0. However, from the second NOT gate here 0, when it is inverted, this will becomes 1. So the probability of 1, that means we can have 1 here and 1 here, and we should have 0 here and here. Since we have I1 is equals to 1, we have 1 here. So we know that the Q1 which will generate the logic state high. However, here will be 0 since it is connected to 0, and this will be 0, and here we should have 1 and this should be 0. So only Q1 will be high, like what we have seen from the truth table. Now if we apply 0 and 1 here, we now be able to see only Q1 will be high. And what will happen if we apply 1 and 0 at the input? 1 and 0. Now this will becomes 1 and also this will becomes 1 from this, and we can see that this should be 0 and this should be 1, and we can have here, we can have 1 here, and since this is 1, this will be 0 and this will also be 0 and this should be 1. So we can now be able to see that only Q2 will be producing a logic high. Therefore from this state we have 1 and 0 at the input, this will be high. So when we have 1 and 0, we now going to have Q2 will generate a logic high. I will later give an example where we can be able to use this to control the LED. And finally, what will happen when we apply logic 1 at both the input? We have 1 and 1, and since we have 1 and 1, automatically we know that this will be 1, this will be 1, and all the others will be 0 here, this will be 0, this should be 0, this should be 1, and here we should have 1 and this should be 0. So only this AND gate, since it has both high or logic 1 at the input, the output will be high. Therefore when we have 1 and 1 here, we can see that Q3 will be high, and it is proven by this truth table. So from this second diagram we can able to generate the truth table, and this truth table, by using this truth table we can also generate the second diagram. Now we will move on to the expression. How can we generate the expression of this particular 2 to 4 decoder? And finally we will give an example to this particular 2 to 4 decoder, and why do we need such decoder in an electrical or digital circuit. To generate the expression for the 2 to 4 decoder, we can simply look at the output and the input from the truth table, and we can say the first one, which is the Q0, which will be equivalent to I0 and I1, and both will be inverted. That means when the two input I0 and I1 is 0, and when we invert, Q0 will become 1. And now from the second output we have the Q1, which we can simply look at the truth table, and we have I0 and we have I1. Since I1 is already 1, we will now only invert the Q0. So we can, from this expression, we put a bar on top of I0. Now we can have Q1 as having a logic high. And for the Q2, you can be able to do the same, since we have I0 and I1, and when I0 is 1 and I1 is 0, we only have to invert I1 to produce Q2, which will be equals to 1. And finally, we have Q3, where we have I0 and I1. By just looking at the truth table, since both of them is 1, we can leave it like this. When I0 equals to 1, and when it is AND with this particular AND gate, it will give us the output which is high. So this can be seen from the circuit, where we have both the input which is inverted and then passed through the AND gate. So we can have I0 and this one will be I1. When we invert both, it will now give us Q0 is equals to 1. So for the Q0, we can now be able to draw that we have I0 and to the AND gate, and we have I1. This will now give us Q1 is equals to 1. And we can see from this Q2, we can say I0 is directly connected to the AND gate, and we have the NOT gate which is connected to I1. So when the I1 is inverted, it will now give us Q2 is equals to 1. And finally, we can have the AND gate, which we connect I0 and I1, which will now give us Q3 is equals to 1. So this initial circuit can be found in the original circuit diagram. And this is now our expression. So I will give you an example where we can use this 2 to 4 decoder to control 4 LED. Because if we want to connect 4 LED directly, that means we will need more number of pins. But by using a decoder, we are decreasing the number of pins that will send signal to light up the LED, and by using only the bits like the input and the output of a decoder. Now if we have a microcontroller denoted by MCU, and we are assigning 2 pin, which is the pin 1 and pin 2, to control 4 LEDs. And now these 2 pins, if we are now passing it to a 2 to 4 decoder circuit, and we can connect the LED 1, we can have LED 2, we can have LED 3, and we can have LED 4, and it is connected to the ground. And if we have some multiple sensors which is connected to a water level sensor, so imagine we have a tank and we have 1, 2, 3, 4, and all the sensors are connected inside this tank, where we have level 1, level 2, level 3, and level 4. And each of these will have, let's say, level 1, level 2, level 3, and we have level 4. Now what will happen if we have the water which is filling up this tank? So initially when we have water at this level, then this sensor reading will be activated and it will send to the microcontroller. And since it is our controller, when it reads that the phase sensor is high because of the water, it will now send output 1 1. When it sends output 1 1, we can say Q3, Q2, Q1 and Q0. So from our previous discussion, when these two pins are high, that means only this LED will light up and it will indicate to a person that the level of the tank is at level 1. Now when the water is increased to level 2, now what will happen? For the level 2, we all know that this will be high. So that means it will now be able to send 1 and 0, where pin 1 represent I0 and the pin 2 will represent I1. So when we have, for example, 1 and 0, which is the input to the 2 to 4 decoder, this LED will now be able to light up and all the other LED will be low. And when the water reaches level 3, now what will happen? The pin 1, from this we can see that this will be 0 and this pin 2 will be 1, and in that case this LED will go on. And finally we can have this pin 1 is 0 and this one is 0 when the water reaches the sensor 4. Now the microcontroller will produce a bit 0 0 at these two pins, and now when the 2 to 4 decoder detects that we have two logic level at the input, now it will give out logic 1 to level 4. So this is how you can be able to design a indicator for a particular application. And because it is important for you to understand this system, you can put it into a practical use by knowing the theoretical values and how you can apply this theory into practice. Thank you for watching our video. Kindly subscribe to our channel and share this video with your friends so they can also be able to learn.